lesson 4.3. Today we're going to be talking about the greatest common factor. So what is a greatest common factor? So basically the greatest common factor, or also called the GCF, is the greatest number that is a factor of both numbers. So basically when you factor two numbers out, what number is going to be the biggest one that they have in common? This is going to be something very useful that we use with simplifying both expressions and monomials and binomials and all kinds of things like that in the future. So there's two different ways that you can find the GCF. The first way is by finding the prime factorization. You'll want to use this especially if you're dealing with really big numbers, like numbers in the thousands or in the hundreds and things like that. But I did it with two smaller numbers just to show you how it works. So basically you find the prime factorization of all the numbers. So I did the factor tree, and I figured out the prime factorization of 20 is 2 times 2 times 5. And then I broke down 12 and did the factor tree for 12. And I found out the prime factorization of 12 is 2 times 2 times 3. So basically, what I realized is that this number has two 2's in common, and this number has two 2's in common. So basically, 2 times 2 is the greatest common factor, which is 4. So 4 is the GCF for these two terms, and we found that out by looking at the biggest numbers that they have in common. Now 5 is the biggest number total, but this number doesn't have a 5, so it doesn't share that factor. Alright, the other way of doing it is listing all of the factors. So basically this one's pretty easy if you come up with smaller numbers. So the way you do that is to list the factors that make that number. So basically we work from the outside and we work in. So we realize that 1 times 20 gives you 20, 2 times 10 gives you 20, 4 times 5 gives you 20. That's all the combinations that will give you 20. Then I found all of the factors for the number 12. So 1 times 12 gives you 12, 2 times 6 gives you 12, and 3 times 4 gives you 12. Then I went ahead and circled all of the factors that both of them have in common. Well, they both have a 1, they both have a 2, and they both have a 4. So this shows us that the greatest numbers that they have in common is 4. So 4 is the GCF of those numbers. Now let's go ahead and do some examples with this. Alright, for the first two examples, we're going to find the GCF, or the greatest common factor, for the numbers listed. Now I'm going to do it two different ways for each of the numbers, or each of the problems, so that you'll get some exposure to both ways, whatever way is easier for you. If you like to list the factors, then I'll do that example so you can see it. If you think you're going to like doing the prime factorization, I'll do that as well. So basically both are going to give you the right answer. You just need to find which one's comfortable for you. Alright, so the first pair of numbers is 6 and 24. So I'm going to go ahead and start off by listing the factors of 6. So I know 1 times 6 gives me 6, and I know that 2 times 3 gives me 6. And that's all that we have. Now for 24, I have 1 and 24, I have 2 and 12, I have 3, I'm running out of space, hold on. 24, 12, 3 and 8, 4 and 6. And those are all of our factors. So basically now I'm going to go ahead and circle all the factors they have in common. So 1 is in common, 2 is in common, 3 is in common, and 6 is in common. So basically which one's the biggest number out of all of those that they have in common? 6. So 6 is the GCF of both of these numbers. Now you can also find this out by doing the prime factorization. So if I took 6 and I realized that 6 is 2 times 3, then that would give me, that's a prime factorization of 6. And then if I do 24, I have 2 times 12, and then I break that down into 3 times 4. So which numbers do they have in common? They have 2, 2, and 3. 3. So 2 times 3 gives you 6. So that's how we get the GCF. Alright, we're going to go ahead and find the greatest common factors of 3 numbers now. So let's go ahead and list the factors. So 10, we have 1 and 10. We have 2 and 5. And that's it. So for 25, you have 1 and 25, and you have 5 and 5. So that's all you have for that one. 30, you have 1 and 30, 2 and 15, no, 3 and 10, 4 doesn't go into 30, and 5 and 6. So 5, 6. So which ones do they have in common? They have 1, they have 5, and that's it. So we see that our GCF is equal to 5. You can also figure this out by finding the greatest, or the prime factorization, and you'll figure out that 5 is the biggest number involved in all of them. Alright, so these next two examples, they're using the factoring method. So basically, we're going to be factoring out something that both of these terms have in common out to an outside of the parentheses. Now, basically what we're doing this for is eventually you're going to be simplifying equations, expressions, binomials, polynomials, and you're going to somehow not be able to solve completely, but sometimes you will be able to bring some things out and simplify as much as possible. So, that's what we're going to do here. So we're going to find the GCF of both of these numbers and pull it out of it. So, for D, we have 2 times 2 times D is a GCF of this factor. Now we're going to go ahead and find the greatest common factor of 8 and 4D. So we have 2 times 4, and then we have 2 times 2. So we see that 2 times 2 is the greatest number they have in common, which is 4. So we're going to pull a 4 out of each of these terms. So that means if we take 4 out of 4D, we're just going to be left with D. So we're going to have 4 on the outside. We took the 4 off, and then plus. Now we're going to take the 4 out of 8, which leaves us with 2. So this is now our new factored answer. So basically we did the reverse of distributive property. We did the reverse. We pulled something out instead of putting it back in. Alright, so we're going to go ahead and try to factor this one as well. So the first step we have to do is go ahead and do the prime factorization of both of these terms. So first I'm going to find the prime factorization of 3x squared. So 3x squared. Now can we break down 3 anymore? No. So we have a 3. Now we need to break down the x squared, which is x times x. So 3 times x times x. That's our prime factorization. Now we're going to go ahead and find the prime factorization of 9x. So 9x. If we break down 9, we have 3 times 3, and then we'll have times x. So that's the prime factorization of that term. So now what is the greatest factor that you have in common? So we have a 3 in common, and we have an x in common. So what we're going to do is take a 3x out of both of these terms. So that means 3x is going to be on the outside of the parentheses, because that's what we're taking out of both. So just like when we distribute, we're putting it into both, now we're taking it out of both. So we're doing the reverse. So if I take 3x out of x squared, I'm just left with x, because I took the 3 off, and I took one of the x's away. So now we're just left with x. 9x, let's go ahead and take 3x out of that. If we take 3 out of 9, we're going to be left with 3. And if we take x out of x, we don't have any more variable left. So our factored form is 3x times x plus 3. That is our answer. So here's our answer here, and here's our answer here for pulling out the greatest common factor of these terms. Now let's go ahead and read a word problem. Now what would this kind of look like in life? It says Marta is cutting a 16-inch and a 28-inch sub for a party. How long is the longest possible piece if she wants them all to be the same length? So basically we have one sub that's one side, we have another sub that's another size, and we're basically trying to figure out, well, what's the biggest pieces can we cut so we have even pieces cut off. So we're going to go ahead and figure out what is the greatest common factor that they both have, so that way we'll know that that is how big we can cut our sandwiches. So we have to go ahead and factor out both numbers. So in 16, let's go ahead and break it down. We have 2 times 8, and then we have 2 times 4, and then we have 2 times 2. So basically we have 4 2. So it's 2 raised to the 4th power. That's the prime factorization of 16. Now we're going to go ahead and find the prime factorization of 28. So I'm going to write 28 up here, and we're going to break it down. So what times what gives us 28? Well, we have 4 times 7 gives us 28. And then we have 4 times 4, or 2 times 2 here. So we have our prime factorization is 2 squared times 7. So our prime factorization of this is 2 to the 4th power. Our prime factorization of this number is 2 squared times 7. So what do they both have in common? I see that they have 2 2's in common. So if you have 2 times 2, you're going to get 4. So 4 is a GCF. Now this tells us that we can cut 4-inch sandwiches and have it evenly cut out the first sandwich, and then cut 4-inch sandwiches from the big one, and you won't have any left over. You will have used all of the sandwich equally. So our final answer would say that we're going to be cutting them into 4 inches apiece. So that's our final answer. Alright, you may need to watch this one more time. It can get a little tricky, but sometimes if you watch it just one more time, it might click. So go ahead and watch it again, look in your book and look at some examples, and come bring your questions to class. I'll be happy to answer them. Let's go ahead and look at a few on your own questions. Alright, you have several problems to do for me. Number 1, find the GCF between 6 and 8. Number 2, find the GCF between 12, 24, and 36. Number 3, go ahead and factor out what the greatest common factor between 3n and 9. Number 4, factor out the GCF between 15 and 20x. And then number 5, find the GCF between 36a cubed b and 56ab squared. Good luck. We'll see what you get tomorrow.